Welcome to this session on network representations of a project. In this session, we learn about a, an important tool for project management that is known as the network representation. Network representation extends multiple advantages in project management to a project manager. It helps in the analysis of the various activities and their interactions among each other. We are able to get an estimate of the completion time for different activities as well as the project duration. We are able to get an idea about the various constraints in terms of resources and time, and it also helps in handling the uncertainty which might be associated with some of the project activities or project completion. Now, we begin with trying to understand the need and importance of network representation in more detail. So it provides a visual aid to a manager which helps in develop a better understanding of the different activities and the interactions between those activities. It helps a project manager to analyze problems and understand how the project gets completed, and also identify some of the critical activities which are likely to delay a project, and hence they can be explored for a possibility of rescheduling. So all these we'll study with the help of an example in subsequent slides. So I have been using the term activity time and again in this session, or would be using it in future slides also. So we need to have an understanding of what does the word activity mean when we are talking about a network structure in a project. So activity is basically the building block for any project network. If you recall from our previous session on work breakdown structure, then we had divided the project into several tasks and activities. So when each of the activities is handled by an individual or a group as to be able to get completed, so different activities combined together help us achieve the project completion. So it is the elementary unit of analysis in a project network, and it constitutes the small amount of work which helps in achieving the project completion. Now each activity is associated with a set of resources and takes a finite amount of time, and there might be certain technological or logical constraints involved with a particular activity. That is, one activity can only happen when the previous activity has completed, otherwise it cannot be conducted. So this all aspects characteristics of an activity we will see in subsequent slides with the help of an example. Now we consider an example of a new product launch. We list out a broad set of activities involved in a new product launch, which are identification of market needs, conceptual design, detailed design, creating market infrastructure, project plan, and reaching the market. So after identification of market needs, you go ahead with developing a conceptual design, then you go ahead with developing a detailed design, then you create a marketing infrastructure, you plan your production of that product or service which will be meeting the market needs, and then finally you reach out to the market and have the sales of that particular product or service. Now there are certain constraints or conditions which need to be satisfied, like without identification of market needs you cannot have the activity of conceptual design. First you need to have identified market needs, then only you can go ahead with conceptual design. Similarly, the detailed design cannot be developed unless and until a conceptual design has been developed. So they are interlinked. So we see that these three activities are interlinked. The first activity will be identification of market, then conceptual activity has to happen, and then the detailed design can be had. And also the final product, when we reach out to the market, it can happen only when we have created the marketing infrastructure as well as we have planned the production. So once both these activities have happened, then only you can reach the market. So these are what we call as constraints or conditions associated. We have to consider the activities as well as the constraints while developing a network diagram. Now let us proceed to the next slide, in which we discuss how we develop a precedence table based on the activities and the constraints given. So the same example I'm taking, the broad set of activities involved in a new product launch. Now we list out the activities in a table. So each of these activities are listed above and then down in the form of a table, and any activity which precedes a particular activity, that is called its predecessor, while an activity that follows an activity is called its successor. So as I said, the first step is activities of identification of market needs. So it doesn't have any predecessor, so we write down none over here. And after identification need, detailed design step, conceptual design has to happen. So activity B follows activity A, so it is its successor. It is listed as its successor in this particular column. Now once we have done the conceptual design, then we see that its predecessor, before it this A activity was done, so it is listed here. After conceptual design, we can go ahead with creating a detailed design, that is activity C, and as well as parallelly we can also initiate creating marketing infrastructure. So C and D can happen in parallel, these activities, two activities, and they are the successors of for activity B. Now next is the activity C. Now C activity has its predecessor, that is previous activity, as activity B, so it is listed out here. And after the conceptual design, we are going ahead with planning of our production. So this is the successor activity for this activity C. Next is the activity D, which is the creating marketing infrastructure. So before that, we need to have accomplished the activity of conceptual design. So B becomes its predecessor, and after creating of marketing infrastructure, we can go ahead with reaching out to the market. So that is its successor activity, that is F. It is listed out here. Now for activity of planning production, its predecessor similarly is that detailed design. After detailed design, we can go ahead with the planning of production. So C is listed out here as a predecessor. And after that, for planning of production, we are reaching out to the market, so F becomes its successor activity. Now the final activity is F, that is reaching out to the market, which has its predecessor as creating of marketing infrastructure and planned production, as we have seen just some time back. And after that, the project gets concluded, so there is no successor activity involved with activity F. So this is how we get a precedence table for this particular sequence or set of activities. Now from a precedence table, we can go ahead with constructing a network for our activities. In this, we use two important representations, which is an arc, which is signified by a line or an arc which has got an arrow at one end. So basically it denotes the direction in which we are proceeding while an activity is being completed, and the node is represented by a circle. Um, there are two main conventions used. One is the activity on arc, and as the name suggests, it shows the various activities on an arc, and this is a more prevalent representation which is used in most of the textbooks of practice. There is another representation which is called activity on node, or AON in short, in which the nodes represent the activity instead of arcs represent the activity. So we'll get a better understanding in subsequent slides how to go ahead with construction of an activity on arc, or AOA as it's abbreviated, diagram, as well as activity on node diagram. So first we begin with an activity on arc diagram. So we take an example. We have the various activities and their predecessors and successors listed out in the table. Based on this table, we'll go ahead with construction of our network. So now in the activity on arc, as we were mentioning earlier, we denote the activities on arcs, and the start of an activity is denoted by a node which represents its beginning, and there is another node at the end of the arc which denotes its completion. So as you can say, activity A is between nodes 1 and 2. So here the activity begins and here it is getting concluded. Here we have to meet certain conditions, or we need to be cautious that there is a condition that a pair of successive nodes can be connected by only one unidirectional arrow. Means between any two nodes there will be only one single connecting arc or arrowed line. There cannot be two, like from one activity there cannot be any the second arc which connects some other node. So there has to be only one arc which connects the two nodes. Now for meeting these conditions, at times we have to incorporate what are considered as dummy activities or nodes. They are just fictitious entities with zero duration, and they don't affect the project completion. Means the precedence and successor relation is not affected. Like for example, in our case, we have incorporated one dummy activity which is denoted by a dashed line, just to fulfill the condition that there is only one arc connecting two nodes. We'll see this later on. So first let us begin with the first activity which has no predecessor. So it starts from node 1, it progresses till node 2, completes at node 2, after which its successor activity happens, or is taken up. So after 2, the successor activity B is initiated and it gets completed at node 3. After B, now B has A as its predecessor. Before this B, we have A. Now B has C and D as its successors. So we have C and D, both activities initiated at node 3, and they continue till nodes 4 and 5. Now after C, we have activity to be taken up at D, which has predecessor as B. So activity D with predecessor B is shown over here as an arc between 3 and 5 nodes. Now its successor is G. successor is E and F. So from 5 we have successors E and F. So it has node 5 has two or rather activity D has two successors, and since we cannot have more than one arrowed line or arc from a node, so what we do is we incorporate this dashed line which removes a dummy activity. So we reach here till node 4, that is C and D activities get completed, and after that activity is taken up. So E has its predecessors C and D, and follower G. So after E activity, G activity is taken up and completed till node A. Now for F, D is its predecessor, so we have D as its predecessor and H as its successor. So after activity F gets completed at node 7, the activity H is taken up and it gets completed till node A. So in this way, after we arrive at activity, after completion of activity H, there is no successor left. So this is where the project gets completed. So this diagram which is shown over here, this is known as activity and org diagram. Next, in the slide we take up what is we call as activity on node diagram. Now same example has been taken with the list of activities and their predecessors and successors. Here we always start with a starting node and an end node between which different activities are distributed or reflected. Here activity on node, as the name implies, that the activities are shown on nodes instead of being shown on arcs or arrows. So first we have the activity A. It has no predecessor, means just after start it is the first activity to be started, and after activity the successor activity B is taken up. After B, the successors are C and D, so C and D activities are taken up in parallel, and after C we have E activity, so C then E because the successor activity is in, and then we take up the activity D for which the successor is E and F. So activity's successor is D, successor is E, and also F activity. When both these activities have been represented in a node, next activity which we take up is the activity E and F. E has G as its successor and F has H as its successor. So we draw line arrows after E and F activities, and the final conclusion happens when activities G and H have been completed, because after there is no successor. So both G and H get completed and we conclude the project. So this particular diagram is what is known as activity on node diagram. In our subsequent sessions we'll study in more detail about analyzing the network diagrams through various tools techniques like CPM and PERT. So for the time being we discussed about the different approaches to representing the activities of a project on network. Thank you. Have a nice day.